So I'm going to talk about going from JavaScript to TypeScript, mainly focusing in Node.js, and how I found that if you change some things in the way you use TypeScript, or at least the way that I use TypeScript, it can make it a bit more helpful. So a little bit about me. My name is Eduardo Sorribas. I've been working with Node for like over 6 years. I have a couple of Node modules on GitHub. You can check them out there. And I recently, I started playing around with TypeScript last year, and then this year I started actually using it at work, like porting some of our projects to TypeScript, and writing actually a new large, well, not super large, but like large-ish web application in it. So this is not like an intro to TypeScript talk. I'm gonna just talk about the way that I used it. So just out of curiosity, how many people, well, who knows what TypeScript is? So basically everybody. Who here writes TypeScript? Okay, not that many. Well, actually quite a lot compared to what I was expecting. Yeah, so TypeScript is a statically typed superset of JavaScript that compiles to plain JavaScript. What that means is it starts with JavaScript syntax and then it extends it so that it supports types. So it looks very familiar. And it provides ways to specify type signatures for your variables, and it has syntax to define your own types. So let's look at an example. So this is a JavaScript file, right? And this is a valid JavaScript file, and it will run. So it's a function add that takes two variables, and it returns the a plus b essentially. That can be the sum or the concatenation depending on the context. And then all of these function calls are actually valid, they don't break. This one looks a bit odd because it calls it just calls it with a third argument that is not defined here, but JavaScript just ignores that. But this file will run, so if you run it, example.js, it will, so the first one will be 5, 5, 23, and 23, and you can see that 5 and 5 are yellow because they are numbers. So this one just adds the first two and just ignores this one, and then these are two strings, so it just concatenates them, and then this one is a number, but it gets converted to a string because it's getting added to a string. So introducing TypeScript in a project is quite simple. You can just, this is just a simple intro. You can just rename the file to TS instead of JS, and then if you save, then you get compile errors. And now I'm getting compile errors already. The first one is, so I have it configured that it shouldn't allow me to do any types. Yes? I'm sorry? Oh, is it? Yeah, sure. Is that better? OK. So actually, if I change this here, I was not intended to have it like this. Yeah, so I only have one type error right now. It's this one. This one has too many arguments, right? I'm calling it with 3 arguments, and it's only 2. But then the rest work, because JavaScript doesn't know anything about the types of this, so it assigns the type to any. You can see when I do I don't have a fancy GUI editor, so you can only see the type down here. So when I see, when I make the types, I just look down there. So yeah, it just assumes that the type is any, but you can specify types like this. So number, and now the other function calls will fail, these two, because yeah, they are not numbers. So only this one is valid. So now that I save, it works. So that's just like a small intro to what TypeScript is. These are very simple types, but it also has a lot of advanced features like generics. It has union types, index types, and a lot of other features. These features are very helpful, especially if you're trying to use APIs that have been defined in JavaScript, which is very loosely typed. And you have some function that in some context it returns like a Boolean, but then it returns an object in a different context, and you're trying to sort of model that in TypeScript. TypeScript type system is very flexible so that it allows, you can use pretty much any API. Some are harder to sort of write typings for, but pretty much any API. But it has limitations, of course. You notice that fairly quickly, even before you start using it. The first one is when you hear about TypeScript is that the types are optional. As you saw before, I didn't put the types in the add function, and it just assumed they were there's this type called any, which is essentially anything. So it's not type safe. Part of that is also the any type, which is not only like when types are optional, you can actually use it, and that just makes it not type safe because you're not checking what any is. It's just you can pass it anything. You can pass it a string, a number, and it works, or the compiler lets it go. And then there's the .d.ts files. These are like if you write a module in JavaScript, but people want to use it in TypeScript, they would usually define these, or like there's a lot of them defined already. The problem with them is, of course, they're written by humans, and they can have errors. I actually had one example this year that was a bit scary. I'm using Express. I guess most people here know Express for Node. It has typings, and in the typings, in Express, when you get a parameter in the URL, you can do something like request.params.id, for instance. And that's always a string. But for some reason, in the typings, they were any. And I was using the ID as a number, and it was working because I was just using it for a query. So it just happened to work. But then when I updated my typings, all my code stopped compiling, even though it was just working right before. So yeah, .d.ts files are really helpful, but they can have errors in them. And like, there's really no way around that. The only way around is just using modules written in TypeScript, but that's kind of crazy. So that's sort of like the known issues with TypeScript. But there's some other ones. Like there's one that people also talk about, which is input-output. What I mean is, like, usually you have, like, this is not a very good graph, but you have a JavaScript program is like a lot of functions and objects interacting. So you have like a function that maybe calls a different function, and then it passes it an object or whatever. And in TypeScript, all these white lines are sort of type checked. Even if you do it, like, if you don't use the any type, but you can do it like you don't use the any type, you don't use like any optional types, you specify all your types, and you make everything really type safe. All these white lines are checked. However, when you go to I/O, which is this red line, that is not checked. And there's no runtime type checker in TypeScript. I've been writing a bit of Go lately, or quite a lot of Go. And in Go, if you get, for instance, a JSON, and you have to parse it into an object, and it checks in runtime that it matches that object. But TypeScript doesn't have that, and it's out of scope for them, which is understandable. But it is a problem, because any object that you get from an unknown source cannot be validated. So you can have like all your types very well checked, and an object that goes around like 7 functions can still, like, if that object initially comes from the I/O, all of those checks sort of like lose a bit of meaningfulness, because then you can have an error in the 3rd function where that object makes it, even though the error should have been where you got it and it didn't match the type. So that's a problem. I have an example here for that. So this is I'm just doing a fetch here. I have a small program that we're gonna try to break. I wrote a program that, let's see if I can run it. Yeah, it's a very simple program. It just gets questions from Reddit, and it ranks them. So it gets the questions that are being asked right now. These are questions that are getting asked right after I started the program. And then if they get upvotes, so for instance, if I vote one of those just randomly, and I'm sorry for if there's any, it's Reddit, so it's what people are writing there. So if I vote this one just randomly, then it should get a vote. And yeah, there it is. It has 2 votes, so it made it to the top. It's if you want to get Reddit karma, then you can see which questions are getting a lot of upvotes. But anyway, this program is written in TypeScript. And I'm doing this. I have a type defined called Reddit posts that it is defined right here. A Reddit post has children that are Reddit posts, and a Reddit post has title, name, and score. Very simple. However, I'm just saying, like, okay, posts is Reddit post, and it's just whatever I get from fetch. And of course, it's a JSON. The problem with this is if I get something like wrong from fetch, so if I change, let's say this to just be a different endpoint like me, this program will compile, and it will break, but it will not break on this line. It will break whenever I'm trying to access that data. So yeah, you can see the error is like, cannot read property children of undefined, and that's like a runtime type error, which is a thing that TypeScript is supposed to prevent. And it's happening well, in this case, it's not so much later, but it's happening after I got the data. So that's a problem. How do you solve it? How I've been solving it, because I write Node.js APIs, and if you write a backend API, like, I mean, whoever uses the API is going to send you whatever they want. So of course, you can use schema validators and all that, but if you have the types, like, it's a bit awkward. So there's this thing called IOTS, and what IOTS is, it's a TypeScript module that allows you to generate TypeScript types that come with their own runtime type checker. In TypeScript, there's a thing called type guards, which is just a function that validates a type. They're usually written by hand, but what IOTS does is it automates this process. So let's see how it works if we want to fix this, sort of. First thing we do is import it. We just call it T, because we're going to use it a lot. Yeah, then we have to redefine these types. So first we redefine the Reddit post type. We do it like this, just call a function type. And then also here, it's very simple. And then instead of string, we say t.string. And this is so that it has its own sort of string type so that it can validate it also. And this actually doesn't make sense because we're creating a type and defining it as a function call, which makes no sense because this is not really the type. This is the type validator, and we call it a decoder. And then we actually can redefine the type. So export type Reddit post is t.type of, and it has this type of helper that you can just pass it an actual type of the decoder. Here it is. What was the error? Oh. Yeah, okay, yeah, that's a function call. Okay, now it compiles. So I just redefined the type using IOTS, and now I get a decoder. I'm not using it yet, but I also have to redefine this one here. Same thing. We don't have this fancy syntax. We just have to say array, and it's an array of the decoder. And again, same thing. This is a decoder. So, decoder. And then again, we redefine the type. Reddit posts. Whoops. Yeah, just add an S here. And this should compile still. Yes, it does. So we haven't done anything yet. We just created the decoder. We have to use it. So the way to use it is instead of saying that this post thing is always going to be a decoder, we just say like, no, we don't trust that. So we have to redefine posts later. So we just add a comment here. But what I'm going to do is like, this is not post. This is just a response. And I don't know what it is in there. And I can actually just say like, this is unknown. Then what I'm going to do is I'm going to create a decoded value that has in which I use the Reddit posts decoder and decode the response. And this gives me, if I check the type of this is a type called either, which is something borrowed from sort of functional programming languages. And either is essentially something it's either something of two types. This is either an error or a post, as you can see here. And you have to check it. You have to, you cannot just like willfully use one of them. You have to check it. So the way we check it is we have to import another library, which is sort of a pure dependency of this. It's called fpts. And then I have to use the either type, which is the one that is there. So an either has like a left and a right value. The left is usually the error. So I just have the is left. I just use the is left to check that whether it's an error or not. So I just do if is left, the decoded value. That means that there's an error here. So I can return. Before I return, I should also like tell the user like, hey, I got something wrong from Reddit. Unexpected data from Reddit API. And I should also like close the program really. I have to do the return so that TypeScript knows that I'm on the other branch of the if. So I can exit here. And then, so if you look at the decoded, in here, I can access only the left value. And the type of the left value, as you can see down there, is an error. But outside of that if, after like that if has been done, I can redefine my response, which is what I have here, like my posts, with my decoded dot write. And here I can only access the write because there's this return here. TypeScript knows like, oh, it's not left, it's right, it's the other value, which is the correct value, which is of type, what was the error? I am. Where? Oh yeah, there it is. Thanks. Live coding. Yeah. So now this posts variable is again of the type that we had before, but it is always type checked, which means that if I run this program again with the wrong API endpoint, it will find right away, like, OK, I got unexpected data from Reddit API, and it doesn't go try to do something with a type that it thinks is not. Yeah, so that's how that works. I use that for like every time I get data from every time in an API when I get input data. Essentially, I use that. There's another place here where we use the API, so we should also quickly do the same. So response, and then if is, oh yeah, we also have to decode it. And then console error, exit, return, and in this case is post, and then it should compile. Perfect. So that's one way to get around it. Of course, like there's no way to enforce that everybody in every part you do, you get any input-output code checks. But if you just make it sort of a, this is a convention we use, then it makes it more likely that at least you will have a more meaningful error message if you get invalid data. And like in the case of an API, you can send a 400 instead of sending that object somewhere else and making it break. I also use this even for stuff that I get from my database. So I don't even trust the onTypes that I define on my database. So that's one of the things where like TypeScript is like it's not like perfect, right? Like I/O. But there's another thing, event emitters. Who here is like has done anything in Node.js? OK, so you guys know event emitters probably. Event emitter is a very common API in Node. It's essentially the same as in the front end, like when you do like add event listener. In Node, we have this very similar API, but instead of add event listener, you use on. And the events are always strings. So you have like some event. So you in this case, you create an event emitter. You add two listeners, which are these two functions here. And then you can emit an event, like some event. And when you emit this, the x in these two functions is going to be of this object. It's going to be that object, right? And the good thing about this is that you can just create an event emitter and pass it, and then different modules that you don't know about can listen to events without it. So it creates it decouples this sort of thing. So you don't have to care about who you have to tell when you do something. You just emit an event. In Node, it's used in stuff, for instance, like when you create a socket or when you create a TCP server, it emits a new connection, for instance. Or when you create a file reader, it emits on data, which is also a stream. But there's a problem with them. So of course, Node has TypeScript typings, and the event emitters, the emit and on functions are defined like this. So event is a string, just any string, or a symbol. And arguments are just any. And the same thing for the on function. An on is an event. It takes the event, which is the string. And then it takes a listener, which is a function that, again, takes any. And in this program that I was just showing you, I am using an event emitter. So the way that the main UI looks is I create the Reddit event emitter. And then I listen on new posts and on post updates, because I want to know when there's a new post and when a post has more upvotes, for instance. But if I check the type inference here, post is any. And that's sort of dangerous. But also, if I say, like, ooh, I have a typo here, and I save, the program compiles. It doesn't tell me anything. Like, there's this decoupling that's very nice with event emitters, But then it also creates this, like, you lose type safety. Like, even though there's no I/O here, you're not going to somewhere like where you get unknown data. It's completely, you are in complete control of all the parts, yet you're still like losing type safety. So it's like this thing, like all these white lines are completely type safe, right? But if it's an event emitter, it's not really. Like, there is some type safety, like you cannot call like emit with 2 T's, but you can emit any event that doesn't exist, that is not defined. So I was working on a project with a really large event emitter this year, so I decided to solve this problem, at least for myself. So I wrote a small module, or like very small, called type safe event emitters. And essentially, it's a redefinition of nodes, or it's actually an extension of nodes type safe of nodes event emitter. And the way that it works is you can install it like this: npm install type safe event emitters. And the way that it works is you come here and you import it. So import so from type safe event emitter, you import type safe event emitter. And the first thing you have to do is you have to create your events type so that it knows which events you have. So I create a type called events, and it's of type object, and it has, for instance, new post, and a new post is of type Reddit post, right? And then it has a post update, and that is of type post update. That's the only 2 events that I have, so that should work. And then when I create my event emitter, I assign it a type. I assign it a type, type safe event emitter, and then it's a generic type, because then everybody can define their own events, and I give it these events. And now nothing has changed. It still compiles, but when I go to the UI and I check the post or the update, for instance, when I check the type, it's a post update now, so it knows what it is. And if I try to listen on a wrong thing, it gives me right away like, hey, this argument of type post update is not assignable to one of these 2. So it has to be one of the events that you defined. And also, like, one nice thing is because editors are configured very nicely in TypeScript, you can autocomplete these events. So if you'd say like em.on, it tells you like, okay, you have these 2 events. And on the other side, on the side where I am emitting these events, which is, for instance, here, instead of post, I can pass it, if I pass it an empty object, it will also tell me, like, hey, that empty object is not a post. So you have to use the actual type. So that's a way to add sort of type safety to event emitters. So it's open source, it's on GitHub, and it's on npm. So you can use it if you're using TypeScript and Node and event emitters. So to summarize, some of the things that I have changed when I started using TypeScript, I was a bit suspicious, especially because the types were optional and all of that. But it was really helpful for me. Like, it really helped me debug my code and navigate it a lot easier. I noticed that there are these weaknesses, but they are inherent, and they are there. Like, if you want to work nicely with JavaScript, you sort of have to accept some of these. So I saw a presentation by Anders Heilberg, the guy who designed this language, and he said, like, it's never going to be completely type safe. But even if it's not, like, it actually gives you a lot anyways. So some of the things that I do is like use runtime checkers for objects that you get from unknown sources, especially I/O, but not only. Like, can be just an unknown module that you don't know what to do. Remove any types from your TypeScript code, and I would recommend just use like no implicit any. So if you have any function that you define and you don't set the type, then that's an implicit any. So you can tell the TypeScript compiler to not allow those. You can use some tool to make your event emitter safe. And not only the event emitters, there are other APIs. I focus on the event emitters because I had to work a lot with them this year, but there's also stuff like streams. Like, node streams are not type safe. They're also like, you can write any to them because they can also be like object streams and stuff like that. And I don't know if anybody has made like a generic type to be able to work with them in a type safe manner. So there's still like some APIs that are defined with a lot of any types. So you can fix them. You can write your own .d.ts files for libraries that you use that don't have them, but you can also write them for the ones that have them. My example with the event emitter, I was using a library that was using event emitter, and of course they were using just the node event emitter. So I could just extend. You can create your own DTS file and extend their API so that I did it so that it used my type-safe event emitter, so that then I get the benefit of using that library with the event emitters, but then I know that the events are at least type-safe, a little bit safer. And yeah, that's all I have. Are there any questions?